So let's talking about safety integrity level. That's a part two of the model two, the risk concept. That is being discussed. So now we come to safety integrity level. Safety integrity level is level of integrity related to some safety integrity function, and a combination of different safety integrity function. We have safety integrity system. So here, this first one have some safety integrity system that is combined for different safety integrity function. Number one, and number two, and number three. So these three safety integrity functions use one logic solver, similar logic solver. The safety integrity function number one and number three and number two use the same final element, this valve that shut down this line that's not allowed product from this tank to this furnace. And of course, each safety function have a sensor to detect some parameters linked to safety valve that you send a command to a final element. So that's safety function one. That's try to mitigate the hazards of a high level in this vessel here. The safety function 2 is this yellow one in here that have this pressure detection here, logic element in linked to this valve, and the safety function 3, that is the pressure in this line here that trigger to this logic element, trigger this valve close. So that's the concept of a safety integrity function that's is related to at three elements. We can have more than one sensor, more than one logic solver, more than one final element, different combination, one safety integrity function. So this safety integrity function need to be assessed and need to be classified in terms of seal. And this seal is always related to some probability of failure on demand that will be used as a layer of protect to mitigate some device. So previously we discussed about LOPA, and in this discussion we define safety instrument and system. So when it says that there is safe instrument system in here, we're talking about this different combination of safe instrument function, and of course there need to be a level, and this level is related to severity of the hazard that will take into account. And in this matrix method to define the safety integrity level, we define also, we consider how many layers of protection there are in place, and then we define the seal level. So another method is the graph method. This graph method considers different parameters such as a consequence of risk parameter, frequency and exposure time of risk parameter. P means possibilities of failure to avoid hazard, and the W means the probability of unwanted occurrence. And then, of course, for each one of these parameters, I have some classification from A to D, from A and B in here, and the W. So in the end, depends on the classification we get in the level of the seal, depends on the demand for this function, safety integrity function. And of course, as I mentioned before, each seal level is related to some probability of failure on demand, and then this probability of failure on demand takes into account the calculation of the layer of protection to mitigate the risk. And of course, and then we know what's the risk factor reduction, and also important issue also is the availability that we have in each seal level. So seal levels apply safety integrity function is one, or the method that's also used in risk analysis. So another method that is very good to manage the risk as well is what we call bow tie. So the bow tie is show the complexity from the very beginning when we have some failures that can trigger an incident, and then we can have a corrosion in a pipeline, for example, until we get in the pipeline leakage, and then we have this different accident scenario. So between the trigger elements and the top events in the bow tie, we have some control measures, so that we call control measure that can mitigate the trigger events, trigger top event. And so in this case of corrosion, we have a reliability specification and preventive maintenance inspection task to check the corrosion level and to avoid that it comes out in a pipeline. In the case of pipe erosion, disruption, we have this some security to avoid there is some accident or some truck gets this pipeline and damage this pipeline, we have this leakage, or even case of natural disaster, we need to have storm forecast to isolate the area, shut down the process when we have some natural floods, that when the possibility of some floods or other natural disasters can happen. Then, of course, by the other side, if that's the events happen, we can have emergency plan for each one of these scenarios that will mitigate the effect. So the both time you can see the complete loop of the accident from the trigger event to the consequence, and as well as you can manage the control and recovery measures. Some both times are quantitative. You can in the end input the frequency of such accident scenario here by calculating the probability of recovery measure and the control measure to mitigate such effects in here. And of course, that depends on the software that we have. And in the end, we have what we call consequence and effect analysis. So the idea of the consequence and effect analysis is to calculate the area that's the accident will affect. So it depends on the type of accident scenario. You can have an explosion, a jet fire. Here we see in different zones. The one that is closer to the source of hazard is the worst one. And then we can plot such vulnerable effect area of such accidents in some surrounded area and see which are the community locations that will affect for this scenario. So that is the basis to calculate the number of deaths that will happen in surrounded area of a plant industry, and in the end we have the final calculation by combining the frequency of the events by the consequence. And that's a very important method that is used in as defined in the uh, as defined in the Civil Directive, for example, or to define these individual risk, ISO risk, risk curves, as well as the societal risk plots. So this consequence analysis is essential and is applied for chemical industry, oil and gas, and other that deal with dangerous products. Another very interesting technique that is we call risk-based inspection is a qualitative method. So we have here at the beginning, we use the FEMEA template. We have, for example, a tank with different types of failure modes, and that's are triggered for causing different phases. Then we define the co-occurrence of such failure modes and consequence. Then we need to mitigate such risk that are not tolerable. Here we are not demonstrate non-tolerable risk because it's just a simplification of the FEMEA. We are now interested in the ones, we already select the ones that are not tolerable, that is in here. And during the FEMEA, we just say that is mitigated for preventive maintenance. So in inspection, in RBI, we need to define the type of inspection, non-destructive test that should take place. So for example, in case of corrosion, we implement non-destructive tests, ultrasound tests, probability degradation analysis, and inspection in every 1 year in order to measure the evolution of such corrosion and avoid that can trigger a major accident. So actually we have different types of predictive maintenance. We can apply for this case radiographic methods or ultrasound methods to detect the degradation of corrosion. And in this case, we are able to use the information here to predict the probability of degradation in time and predict the time that will trigger the events, and of course propose some preventive actions before to avoid that. The whole idea is to identify the failures before we have functional failures. So is that so-called PF interval. So we have a potential failure. We need to detect the potential failure before it becomes a functional failure. Depends on the methods. We have different window of time to detect the potential failure and implement the action before these accidents happen. And that's what we have in case of the predictive maintenance applied based on the RBI recommendation. And then those are the basic the risk analysis applied for major accidents as well as for other type of accident scenario and hazard that's posed in the process. So depends of course each characteristic we will need to apply different methods. But now we have a new approach and new methods that can also must also be applied for risk management. So what we have is a new. So the first one is human factor. So human factor is in the end the main objective is to assess what's the effect of human error in a safety. So the human error can affect safety by a wrong maintenance, a wrong installation, or even a wrong design, wrong operation. And these human error are triggered in the beginning for some combination of some human performance factors or ergonomic, psychological, psychological factors, physical conditions that will induce for your omission or commission error, and based on human behavior that is defined by the test that such employee are doing, they can have a human error. So human error is considered important. It's very interesting because nobody denied the importance of have this human error analysis, but hardly you can see a proper, a real implementation of project, and that needs to be part of risk analysis. So here's an interesting type of risk analysis concept applied for emergency. That's define the time of diagnose and detect some problems and the chance to have the probability of to have error. So higher than 10 minutes, the probability to have a wrong diagnosis and an accident is very high. So we need to consider such a type of analysis in risk when we perform risk analysis. And then we can have a hybrid risk analysis. Here we can see a FTA that have a top scenario as a shutdown plant or a trigger or accidents in a physical asset. In this case was for a considered a platform, calls for two human error that are omission and commission error. And this basic event in the flow tree is fed by a bow tie. So you can see here that the bow tie is triggered for the emergency shutdown valve, and then there we have a top event that's the valve fail, and then here we have the control room actions mistake that cause a plant shutdown, and what causes plant shutdown in the second case here is the both control room and operator action mistakes. So combining human error in your risk analysis will give you a more proper idea, and also you'll be able to mitigate the human error that affects the top event, the accidents. Other important new approach that is taking place and is not spread out mostly in oil and gas industry, chemical industry, that's very important, is what you so-called asset integrity management. The concept of asset integrity management is define the elements that are related to major accidents, and that elements are called safety critical elements. So safety critical elements need to be part of asset integrity management, and that they need to such safety critical elements are the ones that trigger a major accident. So it can be a hardware, a software, a human error, combination of them that are classified as safety critical elements. And then, of course, you need a program, and this program needs some elements such as reliability, inspection, risk management that we're discussing now, and human factor. That's our part and the basis for asset integrity management. So asset integrity management nowadays do not have a specific standard, and some companies have high programs implemented, but others not. So in the future, we expect that we already have some asset integrity management program and procedure and standards to give as a guideline for different industry. So as conclusion, the risk management in the end try to avoid major accidents and mitigate all type of damage in employee health. So because of that, a lot of investment are doing during the project phase since the concept to operation, but these efforts need to go through the through the operational phase, and that's the big challenge. And in some cases, risk analysis is not enough. We need to also to have maintenance, preventive maintenance, reliability, and other issues human error considered as we define for asset integrity management program. As I mentioned in the beginning, we have to apply different analysis in different phase. Other very important concept that we need to have. So, for example, if we apply hazard analysis after the design, we're not able to modify and implement a lot of recommendations from HAZOP, so it's too late, and we made a big mistake in our risk management. So it's very important to have it clear and which phase, which information each risk analysis needs to be fulfilled in order to implement that. Will be comments in the following models during the risk management training that we will be speaking about of each one of such individual analysis. Another very important point about risk in the end is the risk perception. So risk perception for a society, and when I sell society, I'm talking about not only the leaders in the organization, but the whole society stakeholders. Going up and down depends on the memory and the historical of major accident that's happened. So whenever there is some major accident, the risk perception goes up. So we can see that when the Fukushima nuclear plants accident was happened. So in many places in the world, there were people would like to shut down their nuclear plants because they believe that such a major accident can also happen there, and the consequences are very damage is very high for the society. Because in this point, whenever some such major accidents happen, the perception of the risk increase. And of course, when this perception outside the company, the organization increase, we also have perception inside the organization. And in this time, of course, many nuclear plants starting to discuss their procedure to assess again their risk. And this is the level and the big challenge of risk managers to keep this risk perception high for the whole society. To do that, you have to put a lot of effort in communication about the hazard, the risk, the necessity to implement such a recommendation, defining risk analysis. But it's always a challenge. What's happening in reality? That's from time to time. When you pass a very long time without a major accident, the risk perception goes down, and then when some accidents happen again, they goes up. That's just a reference for the training risk analysis as well as I said integrity management. Just demonstrate what the content of material, most of material, all the material are in this book. That is the book for the reference of this training. But of course, we have also one chapter, six, the chapter 6 of this book, also related to safety management for oil and gas industry. So you can get the reference in this book. In this book, you have more all the reliability engineering tools necessary to since from concept to design to the end of design phase that need to be applied to keep the equipment in a high level in a state as good as new. That includes also the safety critical elements, and that means the equipment that can trigger a major accident in case of failure or can mitigate the risk accident. So thanks for your attention. Let's move on to the next model.